I just want to run through some other combinations of motion maps and kinematic graphs. So let's say that you're moving to the right. I'm going to make to the right positive. So at 0 seconds, you're already moving at, say, 9 meters per second. And then at 1 second, you're slowing down. So at 1 second, you're traveling at 6 meters per second. At 2 seconds, you're traveling at 3 meters per second. And then at 3 seconds, you have stopped. What would that look like? Well, I'm going to call this 0 meters. So if we started right here at 0 meters at 0 seconds, any accelerated motion, constant acceleration, is going to be represented by a parabola on the position time graph. So that would look something like this. So you're still moving to the right. You're at 0 meters. You're still moving to the right. And I said right is positive. So you started here and you're going to the positive direction. Well, on this, the position is on that y-axis, and so positive is up. Okay, so it would look something like that. Okay, remember that the slope of this represents the velocity. Okay, and so this levels off. At the very beginning, if you were to use the whiteboard marker as like a tangent, all right, tangent like where it hits the curve at one point, it's pointed up at the very beginning. If I put that tangent to that curve at 0 seconds, it's pointed up. And the slope of that would represent 9 at that moment. At 1 second, the slope would be 6. At 2 seconds, the slope would be 3. And at 3 seconds, the slope would be 0. It levels off to a slope of 0 because it's stopped. Now you plot these points here. That's positive 9 meters per second at positive 9, so that'd be like 9 right there, at 0 seconds. And then at 1 second, you'd have 6. At 2 seconds, you'd have 3, because that's what the numbers correspond to. At 0 seconds, at 3 seconds, it would be at 0. Okay, so your velocity is a constant, uniformly decreasing down to a stop. All right, a stop right there. Now, what's the slope here? The slope is going to be 0 minus 9. It's always ladder minus initial. Right? That's 3 seconds. All over 3 minus 0. All right? This is always a final point minus the initial point. So that point is 0 meters per second at 3 seconds. This is where the 0 and 3 come from. And the last point is... the initial point, it's always final minus initial. So the first point is 9 all over 0. And you're doing rise over run. So that whole thing with y2 minus y1 over x2 minus x1 that you learned when you did slope, that's where the negatives come from. Okay. So basically, you're changing velocity over the change in time. So that's negative 9 over 3 is negative 3 meters per second over seconds, and so negative 3 meters per second squared. That again is what? It's the acceleration. How do you go from 9 to 6? You subtract 3. How do you go from 6 to 3? You subtract 3. How do you go from 3 to 0? You subtract 3. The velocity is changing by negative 3 meters per second every second. So down here, negative 3 meters per second, that's constant. And we represent that with an arrow in the opposite direction. So the acceleration is pointed this way. These are all the same length because they all represent negative 3 meters per second squared. Okay? So go down here to negative 3 and graph it. That would be your acceleration graph. Okay? Yeah, all right.